lowest common multiples, LCM. The LCM of two or more numbers is the first common multiple of these numbers. LCM can be determined using the method of 1. Listing the common multiples. 2. Repeated division. 3. Prime factorization. Example 11. Determine the lowest common multiple of A, 2 and 3. Solution. Method of listing common multiples. So we are going to solve this question using method of listing the common multiples, which is the first method. First, we need to list the multiple of 2, which are 2, 4, 6, 8, and 10. Okay, 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8, 2 times 5, 10. After we list multiple of 2, we need to list multiples of 3, which are 3, 6, 9, 12, and 15. From this list, we choose the lowest common multiples, which is 6. Okay, the lowest common multiple here is 6. 6. Okay, next, in example 11, we need to determine the lowest common multiple of question B, 3, 6, and 9. Okay, this time we are going to use the second method, which is repeated division. Okay, using repeated division, we draw this horizontal line and next this vertical line. After that, we list the number from the question on the right. 3, 6, and 9. Next, we need to divide the numbers repeatedly by a divisor that can divide completely at least one of the number. So, we are going to divide these numbers by 3. 3 divided by 3 equal 1. Next, 6 divided by 3 equal 2. 9 divided by 3 equal 3. Okay, the second step. After this, we still need to divide this number. 1 divided by 2. So, we just write 1. Because 1 cannot divide by 2, we bring down 1 from here to down here. Numbers that cannot be divided completely by the selected divisor are brought down for subsequent division. So, we bring this one down here. Okay. So, 2 divided by 2 equal 1. 3 divided by 2 equal 3. Okay, because 3 cannot divide by 2, so we bring down 3 here for subsequent divisions. Okay. Next, we divide by number 3. 1 we bring down. Okay, we bring down 1. Next, 3 divided by 3 equal 1. Okay, division is continued until all the quotients become 1. Thus, the LCM of 3, 6, and 9 is 3 multiplied by 2 multiplied by 3 here. Okay, which is 18. So using this repeated division, we can find the LCM by multiplying this number on the left side. Okay, let's look at another method, which is using prime factorization. Determine the lowest common multiple of 3, 8, and 12. Okay, the solution is using method of prime factorization. First, we need to find the prime factorization of each of the given number. Okay, we need to find the prime factorization for 3, which is 3, and find prime factorization of 8, which is 2 multiplied by 2 multiplied by 2. Okay, next is prime factorization of 12, which is 2 multiplied by 2 multiplied by 3. We need to arrange it same number all together lah. First, because 3 to the last here, 3 we put it on the last. Okay, so how can we determine the lowest common multiple? Okay, we need to bring 2 down. Okay, next multiply by, okay, we bring another 2 down here. Next multiply by another 2 and multiply by, bring down the 3. So the LCM of 3, 8, and 12 is 2 multiplied by 2 multiplied by 3, which is 24. This is the method of prime factorization. Okay, this is an alternative method that you can use to find LCM. Okay, first is to identify the greatest numbers. Okay, this is the question. You identify which one of these numbers are the greatest numbers. Okay, so this is 12. 12 is the greatest. 12 is the greatest number. Okay, next, list the multiple of the greatest number. So you need to list the multiple of 12. Okay, after you list the multiple of 12, which is 12, 24, 36. Okay, the third step is to determine the lowest multiple that can be divided completely by all of the other given numbers. So from this multiples of 12 here, we need to determine which one can divide completely if we divide it by 3 or by 8 and by 12. Okay, 12 can be divided completely by 12, but 12 cannot be divided by 8, cannot be divided completely by 8. Okay, because it will have remainder. Okay, so it cannot, so we cannot choose 12. Okay, so 24 can divide completely by 3. Okay, so 24 can divide completely by 3. Can 24 divide completely by 8? Okay, yes, 24 can divide completely by 8. Can 24 divide completely by 12? 24 divide by 12. Okay, yes, 24 also can divide completely by 12. So that means 24 can be divided completely by 3 and 8. Thus, the LCM of 3, 8, and 12 is 24. Okay, this is another method. Okay, using this method, I think you can find the answer faster. First, you need to remember to identify the greatest number. Determine the LCM of each of the following list of numbers. A, 14 and 21. Okay, how can we determine the LCM of 14 and 21? Okay, we can use the second method, which is repeated division. So we write, okay, we draw this horizontal line and write the number 14, 21. Okay, I'm going to divide 14 and 21 by 2. So here is 7 and 21 cannot be divided by 2. So I bring down the 21 to the bottom here. Okay, then I'm going to divide by 3. 7 cannot be divided by 3. So I just write down 7. Okay, bring down 7 here, and 21 can divide by 3. I will get 7. Next is I'm going to divide 7 by 7. Okay, so here is 1 and here 1. So we do the repeating division until we get the quotient all 1. Okay, next what we need to do to find the LCM is to multiply this number. 2 multiplied by 3 multiplied by 7. 2 multiplied by 3 multiplied by 7 equal 42. So the LCM is 42. Determine the LCM of 3 and 7. Okay, how can we determine the LCM of 3 and 7? Okay, this is a common repeating division. This time I'm going to use listing the common multiples. Okay, first I'm going to list multiples of 3. Multiples of 3, which are 3, 9, 3, 6, 3, 6, 9, 12, 15, 18, 21. Okay. Next, I'm going to find multiples of 7. Okay, which are 7, 14, 21, 28, and so on. So, from this list, the lowest common multiples here, okay, is 21. Okay, this is same for 3 and 7. Thus, the LCM equal 21. Okay, do you understand? I hope you do. Okay, let's look at how do you solve problems. Okay, in this question, canned coffee is sold in 6 cans per box and canned tea is sold in 9 cans per box. Ainon wishes to buy the same number of canned coffee and canned tea for her sister's birthday party. What is the minimum number of boxes of each type of canned drinks she needs to buy? Okay, so we are going the learning standard here to solve problem involving LCM. Uh, what we are going to do first is understanding the problem. Number of can of coffee. Okay, we can look at here. Canned coffee is sold in 6 can per box. Okay, number of can of coffee 6. Okay, tea is sold 9 cans per box. And number of can of tea is 9. Okay, after we understand the problem, find the minimum number of boxes of each type of canned drinks I need to buy. Okay, second step, we need to devising a plan. Find the LCM of 6 and 9 to determine the same number of cans. Okay, in this third step, we are going to implement the strategy. First, we list the multiple of 6. After that, we list multiple of 9. And we find out the LCM of 6 and 9 here, which is 18. Okay, number of boxes of canned coffee equal 18 divided by 6 equal 3. Number of boxes of canned tea equal 18 divided by 9 equal 2. Therefore, the minimum number of boxes Ainun needs to buy is 3 boxes of canned coffee and 2 boxes of canned tea. After that, the first step is doing reflection. Number of canned coffee equal 3 multiplied by 6 equal 18. Number of canned tea 2 multiplied by 9 equal 18.